Let's do example 1 on your notes. Before doing that, take a screenshot of all these steps. It looks like a lot of steps, but as I said, it's better to be use a methodological method. I cannot say it. Use the method in order to do our equations so that we know exactly what we're doing. So let's get into it. So it says, graph the following equations on the z-axis over the given domain, given coordinates of actual intercepts and endpoints where applicable. State the range. Okay, so we have to graph and we have to state the range. So let's look about what the step says. So the first step says, rearrange the equation algebraically to look y equals mx plus c. In this case, I already have done that. It's done like that. It's given as y equals mx plus c, so I don't have to do anything. Now, let's identify the gradient. That's the first step. So gradient is negative 2. Is negative 2. If I want to write it as rise over run, negative 2 over 1. And is negative. Therefore, it's going to go downwards. Downwards. Okay, so identify the gradient, determine the trajectory of the line is negative. Done. So we've done this step. Identify the y-intercept. So the y-intercept is positive 3. And if I write them, it says identify the y-intercept, write it as a point. So the coordinates of it is going to be 0, 3. Wonderful. Done. Calculate the x-intercept, because in these questions they're asking to graph the following equations on the z-axis over the given domain, given coordinates of the actual intercepts. That means the x and the y-intercept, if applicable. It's not going to be applicable always, but to find the x-intercept, what do I have to say? So to find the x-intercept, I have to say when y is equal to 0. So when I do that, what do I get? I'm going to use, okay, I'm using here my formula. 0 is equal to negative 2x plus 3, which means that 2x is equal to 3. Therefore, x is equal to 3 halves. And if I write that as a point, it's going to be 3 halves, 0. Wonderful. So I have done this one. Oh, sorry, not that one, this one. Good. Now it says, calculate the value of y for the endpoints of the domain. Okay, so here they're giving us an example. So I'm going to do that here. I'm going to do it with black, so we have different values, colors to follow. Calculate the value of the y-intercepts. So if the domain is given us as a, b, calculate the value when x is equal to a, and then we write it as a point, and calculate the value of y when x equals b, and then write it as a point. So let's look out here where are our endpoints. So first, when x is equal to negative 3. So I'm going to write it here. So y is equal to what? Negative 2 times negative 3 plus 3, which means that y is equal to negative 2 times negative 3 is positive 6 plus 3, which is equal to 9. Therefore, this point is going to be, now, is it included or not included? It's not included, okay? So negative 3, comma 9, and I'm going to say not included. Or in order to do it clear, I'm going to put a 0 like this. This point is meaning that I'm going to, when I'm drawing it, sketching it, it's going to be an open point. It's not going to be dark like the other one. Okay, now let's look at the other endpoint that I have to do. When x is equal to 3, positive 3. So in that case, it's y is equal to negative 2 times 3 plus 3. That gives me that is equal to negative 6 plus 3. And that gives me that this is equal to negative 3. Therefore, the other point, and this one is going to be included, is x is 3, y is negative 3, and this one is going to be included. Okay, so it says here, I have calculated the endpoints. I have done that. Good. Determine if the endpoints are inclusive. So when there are squared brackets, or not inclusive when there are open brackets. I have done that by determining these points. So I have done all of these steps. Fantastic. Let's look at the next step of what I have to do. Plot the y-intercept in the Cartesian plane. So I'm going to plot my x-intercept. Yes, and before moving on, I just want to highlight something here. What I did is this point negative 3 is this point negative 3 is what I included here, and is what I included here. Just do it visually so everyone is following me. This point 3 is this point 3 is what I put here, and is this point here. Okay, good. Now let's plot our points. So what plot the y-intercept. So my y-intercept, I have it here, is 0, 3. Let's go and use that one. 0, 3. Plot it. Okay, perfect. Plot the x-intercept. So the x-intercept is 3/2, which is 1.5. Agree? 0. So 1.5, 0. This point here is my x-intercept. Done it. Okay. Plot the endpoints of the restricted domain. Remember, included endpoints, solid circle, not included open circle. Okay. So I have negative 3, 9. So if I go here, I have negative 3 here and up 9. Okay, this one included or not included? Not included, so open circle. Okay, good. I can, you know what I should have been doing? Labeling it. I did this super big. You don't have to do it as big, but it's just to make it very clear for you that it's not included. So negative 3, 9. This point here that I had was 0, 3. This point here was 3/2, 0. Okay, and the other endpoint that I have to use is 3, negative 3. So 3, negative 3 included. So again, you don't have to do it as big, but it's very clear that this one is not included and this one is. So this one is going to be 3, negative 3. Okay, so I have plotted my endpoints. Sketch the graph with a ruler. So I'm going to do that. So I'm going to put my line going from this point to this point. It should go through all of the points. Perfect. Ending there because it doesn't go further. Okay, there I have my line. I have done this step. Here, like, to be honest and be super specific, this point, I'm going to do it a little bit because it should go exactly to that point, no more, no less. Exactly to that point. Okay, good. Use your gradient, rise over run to verify your line. So I had my gradient here. I knew that it was negative 2 over 1. First is going downwards. Agree, it's perfect. I can use any 2 points to check that I have done things correctly. So if I go here and I want to check, so I'm here and I go negative 2, so that will be negative 1. Agree, this is one whole unit. Here is a negative 2. Yes, 9. If I go to negative 2, so that will be to negative 7, which is here. Good, negative 7, and then 1 to the right here. So yes, it goes exactly to this point. And if we go and if we check, continue checking, negative 2, 1, negative 2, 1, negative 2, 1, negative 2, 1, negative 2, 1. Okay, so I have done that. Perfect. Label the x and y-intercept plus the endpoints. I did that before. And now we have to identify the range. So that's the final part that we have to identify. So we're going to identify our range and we have it here. We can see it visually. So we're going to say y belongs to, what is the smallest value of the y? The smallest value of the y is here, negative 3. I'm going to put it in pink, negative 3. What is the largest point? 9, largest value, 9. Okay, so when it's going downwards the line, when the gradient is negative, you have to be careful with that we go from negative to positive, okay? So I have it. Now, is this point included? Yes, it's included. I have it here. So I'm going to put it in circle. It's going to be -3. And then goes to +9. And in 9, I made a mistake here. Because this one is included, it's a square brackets. And this one is not included, so it's open brackets. There you go. You know what, girls? Even here, this point, I'm going to put it, I'm going to write it in correct brackets. So I'm going to do it when you write them so that it's super clear what you're doing. This one is not included. That's why it's going to be rounded. And because this one is included, square brackets. Perfect. And I have solved this question. Let's do in the next video the following one, okay?